I'm so sorry for the audio problem. Can you listen me now? I see that there is one person connected. I am trying to advertise the message to all the people. Um, okay, we are four. So I'm audible. Is that listenable for you? If you can write in the chat, that will be very, very good. Perfect. Super. Thank you very much, Edwin. So we are four people in the chat. Well, thank you very much again, and thank you for joining me tonight. For the ones that are in European time zone and the ones that are in the Latin America or other continents, good afternoon. Let's wait a little bit for people to join. And I want to ask while we wait for the people to join. Very good, Mr. Notley. Thank you for joining too. From where are you? Are you listening to this transmission? You are from Latin America, from Europe, from Africa, from Asia. Will be great to get to know from where you come, and also we get familiar until we wait for more people. Houston. Okay, so US. Very very good. Nice to meet you, Mr. Not Holly. At least that's the nickname. So we are five people. Lisbon, Tiago, thank you for listening from there. Lisbon, oh, that's very very nice city. Peru, Edwin, very good from Latin America. Okay, so I think that we will start, even that we are not that many people. The changeling probably also change the flow of the people, but let's start, and probably some people more will join us. So nice to meet you. My name is Juan Pablo, as you probably have seen some of my YouTube videos, and thank you very much for joining me today to the session. The intention of the session obviously is to discuss segment routing, and obviously a little bit of the story of what is segment routing, when we can apply, how we can apply, and what are the main advantage compared to LDP, right? I have been speaking the theory and the content in the videos in the channel, so you can also take a look there, and probably you can see more hands-on lab. Today also my plan is to do some hands-on lab, so you can see in live, and also the most important, I think, that we are in live is that you can ask questions and we can interact to each other, right? We can basically exchange experience on segment routing, on service providers. Probably some of you work in some providers already. So that's a little bit the intention of this session, okay? To make it interactive and to listen across experience between us, okay? So maybe from the people that I see that we are two people only. Do you work in a service provider, or what is your main interest with segment routing? What is the main curiosity across segment routing? Are you working in a service provider, in an enterprise that also have a service provider kind of network? What is your experience with this type of protocols, let's say in service provider environment? Feel free to write in the chat. I am reading all of that, and I can highlight what you write there. think that we don't have more comments in there. Okay, Edwin wrote ISP for and data center. Those are the main technologies that you, Edwin, work on mainly. That's very good. So I believe that also is in the trend of SRv6, let's say as well, right? To provide communication for the provider. That's very good. Okay, so let me share my screen, and I want to deep dive you into a bit of the story and the target of the session, that basically is to go over segment routing. Okay, so let me share my screen. I want to show you what we will have today. So we have this. I'm just preparing the lab a little bit, so then I can show you the configurations and how to enable segment routing basically. But before that, we will see a little bit more of theory of the content. Okay, so the intention of this session is to make a kind of a class, right, of segment routing, and then we can bring it up the questions that you would like to, and we can answer in live, and you can have different opinions or feedback. Okay, so let me first connect to all my sessions in EVNG. By the way, EVNG is the main emulator that I am using for all the YouTube videos and also for all the labs. When I was studying in service provider or in security or in another technology, the main, let's say, the main software that I was using is indeed EVNG. Okay, so now let me connect to my board, and I will show my screen in a little bit. Let me do that here. Okay. Perfect. So give me a second that this change a little bit the way that I set up the things for the live. So now I am ready. Let me share my screen now. Okay. Okay, let me know if you see my screen, if it's visible. Tiago as well said that it's through you're coming from a search provider as well. Perfect. So can you see my screen, right? Okay, perfect, very good. So let me walk you through what is segment routing, but even before, right? Before we jump into segment routing and LDP, that is the predecessor of segment routing, what it came before, right? Obviously, the idea that we have with this type of technologies, it has to appear with a reason, right? It's not that there is an idea of make something very smart and great and implement that. It has to come with a sense and with a purpose, right? And the main idea of I think I'm trying to share. Can you see? I guess I'm not writing here. It's not possible to write, so I will switch over here. Okay, so now it should work. Okay, well, more or less it's work. Okay, so as I was saying, I'm sorry for these interruptions, that I was changing computer to set up the environment because my microphone in the other computer didn't work. But as I was saying, all the sense of encapsulation protocols and label protocols like LDP, like segment routing, they come with a purpose. They are not appearing because we wanted to create something smart, right? Before MPLS and before LDP, if we look in the history, it exists something that we call peer-to-peer model. I don't know if you have heard something about this type of concept from peer-to-peer model, but peer-to-peer model, basically what it does, or what it was trying to do, is exactly the same request that segment routing and LDP were trying to achieve. So you have an MPLS network like you have here, for example, 3 routers as I am drawing, and then you have the CE devices, right? And probably this is common to many of us in our work. We have customer devices, and also we deal with provider edge, with provider devices as well in the middle, right? And provider edge in the left side. So the peer-to-peer model tried to provide communication across different CE devices and the customer, right? And it tried to provide this communication by routing, okay, by passing the traffic from the customer, even not splitting in a VRF, but kind of overlaying the traffic over the routing protocol, either using BGP or either using OSPF, redistributing the customer route. For example, if I run OSPF with the customer, I redistribute the OSPF routes from the customer into the OSPF domain that is playing between the core network. And the same thing when it's redistributed to the other CE. So it tried to provide a solution for communicating the two CE devices. That was the beginning of this sense of why labeling protocols exist, right? The peer-to-peer model defined this type of, let's say, requirement and sense of technology. Of course, then whenever more CEs and different customers are being added into the network, so you have another CE customer that is totally different and totally aside from this customer that already exists, then you need to somehow integrate that customer in the provider, right? And of course, probably they would like to be independent. They want to have this isolation for security purpose and for different other reasons, right? Even they might have the same addressing part behind each customer, and this might also overlap. And of course, this was very hard to achieve in a normal routing protocol because you can run OSPF here, you can run maybe OSPF different process here. And when you redistribute both in the core, if you have the same subnet received from each CE, you will redistribute just one subnet, and then you will have some type of black hole, okay? So that's obviously something that is not desired because you want to provide communication, isolated communication to the customer from all the other networks. So this obviously with more scalability requirements, it became very, very hard to achieve. More customers sum up, harder to provide some policies and avoid loops in the network and avoid suboptimal routing and black hole. And obviously it was not scalable. It has to appear some type of technology that could somehow provide that isolation and make the things easier, okay? And this is where it came up into the picture BRF Lite. The idea of BRF Lite to this type of network. How many of you have heard about BRF Lite overall? I guess many of us are already have heard or have implemented BRF Lite in some point of our professional development, let's say, right? So BRF Lite is a technology that allows you the isolation specifically. It allows you to create a customer and isolate the customer into a particular BRF. A BRF is a separate control plane and forwarding plane that isolates. Apologize, it got broken the connection somehow, and I had to reconnect. Can you hear me? I apologize, the connection got really broken, and I am trying to reconnect again. Please let me know if I'm audible. Perfect. Okay, thank you, Edwin. I start to share my screen just to let's try to see if people reconnect. I don't know, Edwin, if you can comment if this got somehow. We have more people in. Okay, perfect. Thank you for joining. Just restarted the session because it got somehow broken. But you can hear me now and you can see my screen as well, right? If you can comment in the chat that will be very good, please. So then we have the confirmation, and I can I just want to make sure that you listen to me, and then I can proceed to continue, and then we have the continuation of the session. I'm so sorry it got broken again. I hope you can listen to me. Perfect. Okay. Thank you, Edwin, for commenting. That helps a lot. So I hope you listen the part of BRF Lite and also peer-to-peer model, and of course, why we needed to have SRMPLS into the place, right? It was been looking for improving the scalability, as I was mentioning, and the manageability, right, of the providers, and not only providers, but enterprise network as well that gives this type of service, right? So there is where it fell down into LDP segment routing, and then later on SRv6. That SRv6 is totally a site of segment routing, in the sense that the encapsulation and how it works is totally different. And then obviously the next big hop, it was LDP, right? LDP is the protocol that most of us know. It has been broadly implemented in 20 years ago. It improved the way that this delivery of the traffic is being made. So we got stuck in BRF Lite. So basically we have a customer that was in a BRF, and if we have 10, 20, 30 customers, they will be also assigned to a BRF and extended across the core. That part we saw that is not scalable. So how labeling improved that site? Well, if we draw here a similar type of network, like that, for example, and here we have as well the CE devices, as you can see here. Sorry that I also draw many networks aside, but I like to do it because I feel that is more explanatory for all of us. So MPLS LDP, basically it relies, as the name said and as I mentioned, in labels, right? But what does it mean? It means that basically for every customer still will be assigned to a BRF, right? As BRF Lite, still we will have a customer that will have a BRF assigned. On that BRF, we will run any routing protocol. It can be OSPF, it can be ISIS, BGP, it can be static route as well. So that part of the isolation, we will not remove from the network, and we will reuse what BRF Lite was doing. But really the big change and the big improvement with labeling protocols is in this part of the core, okay? So now this part will not be isolated per BRFs. Instead, every device will assign a label to their loopback 0 and all the prefixes in the routing table. So if P has 3 prefixes, including his loopback, P1, for example, here, P1 and P2, P1 will assign labels to all those 3 prefixes. Okay? So, and then it will share those labels through LDP. There will be a session of LDP built up across every neighbor device. So P1 with the provider in the middle, they will establish an LDP session. Provider in the middle with P2, they will establish an LDP session, meaning that LDP also works as a session-based protocol. right? Like OSPF, ISIS, BGP even, it sends hello packets and it has to establish a session for it to work, right? Over that session is that those labels, every PE device will assign labels to their prefixes in the RIP and FIP, and those labels will be exchanged. In that sense, P1 will know what label to use to reach out P2 loopback 0. Okay? And loopback 0 in MPLS is very important because we must have, well, we must not have, but it's ideal and almost a must to have a slash 32 to a PE device. There are some tricks that you can do for still have a slash 24 for playing a layer 3 VPN services with MPLS. But still, in most of the enterprise and provider networks, you must have an slash 32 prefix, okay? And you must have a label for that slash 32 prefix. So LDP works in this type of way, right? Have prefixes in the routing table, assign a label, share those labels and those prefixes in the LDP sessions. Every device know the label of the loopback 0 of each device in the network, of each PE. And also, on top of that, for providing communication of the service between, let's say, C1 here and C2, we have, C2, we have multi-protocol BGP, and probably many of us know that protocol. Multi-protocol BGP basically allow you to create address families, right? VPN-v4, VPN-v6, and this type of way to deliver the services to the customer, putting in a VRF over an MPLS network or LDP network, is normally called VPN-v4 in multi-protocol BGP, VPN-v4 or VPN-v6, depending if the customer have IPv4 prefix here or has IPv6 prefix here. Okay, but this is a little bit aside of the concept of segment routing and MPLS LDP, right? So LDP use that labeling exchange across the PE devices of the loopback 0 of the slash 32. And whenever there is a request from the customer to reach out the other customer in the other end, then everything is based on labels, right? So provider H1 receive the traffic. It see that C1 wants to reach a prefix behind C2. In multi-protocol BGP also there is label exchange, but I will not touch that part because it's also becoming more extensive. So P1 needs to look what is the label for the customer that multi-protocol BGP assign. And once it figures out that, it needs to know what is the label to reach out the loopback 0 of P2. Because those multi-protocol BGP sessions that I just mentioned normally are between the P devices, or there is always a route reflector in the middle, but the next hop is preserved in the same autonomous system. So P1 needs to look for the label to reach out P2. And guess what? It knows the label because LDP propagate that label. So then when P1 receives that traffic, what it creates in the encapsulation is label of the VPN that is assigned by VPN-v4 and VPN-v6, and label of the core of the core or the transport label that this is assigned by LDP. P1 knows the label of the loopback 0 of P2 because P1 listen from provider router in the middle, and provider router in the middle listen from provider H2 in the right side that provide the labels for the loopback 0. So it works in that way, the labeling and stacking. Points to highlight here in a summary. We need to have a session, and there is another point that is also quite interesting in this type of network delivery with the services through the customer, is that some customers, they want to have, if there is, I'm sorry for the drawing that is messy, but I will just add here another router. Some customers, they want to have privilege across the core infrastructure that they cross. They want to go sometimes through the low latency path, for example. So if the path on top, for example, is 100 milliseconds of latency, some customers are able to pay for going over the low latency path across the core. Okay, and those customers that will going through the low latency, they will obviously seconds, and on the downside is 10 if the customer pay this low latency path. And this is where it comes segment routing into the Buenas a todos, se volvió a desconectar. Sorry, it got disconnected again. I don't know if you can listen me now. I tried to improve the connection. Now it's much better, probably. I am really sorry for all these delays and please let me know if this is better now. I believe you can listen me now. I hope so. At least these buttons here, it shows me that yes, that you can listen to me. If you can write in the chat again, that will be very good. So it will help me to get to know that I can start sharing and this will not break again. So that will be very appreciated. You can write in the chat. Okay, perfect. Thank you, Leo. So I will share my screen again. Right, we saw that LDP has the session-based protocol. So we need to have, and now I recover my pen that I like the most. So we need to have a session between the provider and the provider edge in the network in order to exchange those labels that I was just mentioning before, right? So if we have a network like that, with typical as we have here, we saw that we need to have LDP sessions so the LDP sessions can exchange the loopback. And I was telling you when we cut off from the transmission that we might have customers that they might need to have preference in the network, right? There might be a customer that wants have a critical service and they want preference in the network. And for that, they are able to pay more. They prefer probably to go down to have a 5 millisecond latency and then go up to have 100 millisecond, for example. And here is where I stop and I was mentioning that it comes to place traffic engineering. Okay, traffic engineering is that specifically is that providing engineer the traffic across the network infrastructure. Nothing necessarily needs to be a service provider network. It can be an enterprise. It can be any type of network. The idea, or even using segment routing, not using segment routing, using BGP, OSPF, any type of routing protocol, that's also a part of traffic engineering. It's a global design networking term, let's say. So then here is where we have a need of traffic engineering to engineer the traffic. And here is where LDP is not that good. LDP is not, there is no a really easy way to provide this type of preference like I just described now for the customer that have or want to have a low latency path across the core. There is no an easy way to provide this type of traffic engineering for that customer. It's possible to provide traffic engineering from the PE to the PE in the right side, left and right side, but not for specifically only this customer. That part of the traffic engineering is very hard to achieve. And this is one problematic that LDP had and still have. It's not fixed anymore. Another kind of problematic is that latency base, if one customer wants to go over low latency path, LDP doesn't have the functionality to peer or to partner with another protocol that calculate the latency across the network or across the link to provide that engineering or traffic engineering based on latency. That capability doesn't exist in LDP. Okay, so this is another important thing to consider. Another thing is that LDP is not really open to automation, right? LDP is labels exchanged for prefixes. It's supporting telemetry, for example, if we export to a telemetry server, but it's not really open to automation. There is not really a central place where we can provide dynamically the traffic engineering policies, for example, or we can provide visibility across the network other than just exporting to a telemetry server or SNP server. So these terms that I just highlighted here are the reasons why there was a need to move to segment routing and create a new protocol. Or even not a new protocol, but develop something better that will be able to satisfy those needs. And as I was telling you in the beginning, always things comes for a reason. SRv6 also came for a reason that we will have another seminar that we will show why SRv6 came into place and how it's useful across provider networks and when you need to migrate and when you cannot migrate or you should not migrate. But everything comes for a reason, and these are the three main reasons from my perspective that LDP or that we needed, or the people in the groups needed to in authorized group needed to develop something better, and this is basically because LDP is session based. The other thing is that it has a very poor traffic engineering features. It cannot be calculating traffic engineering based on IP SLAs, critical IP SLAs like latency, for example, or delay. And the other is lack of automation. Okay, so those are the main parts why SRMPLS exist. Okay, and something better has to be developed. Someone has different comments, different opinion. Please feel free to write in the chat if you have different perspective than me of why SRMPLS has to exist. If you have any comments, please feel free to write it down and we can bring it up, we can discuss. That's also the intention of the session today, right? I would like to listen from you actually on this part. Do you think that there is any other part why SRMPLS or another protocol had to exist to evolve LDP, for example, from your experience in providers? Feel free to write it down in the chat if you have any thought or any question, comments, or feedback. I will be happy to answer them or discuss and bring it up in the table. Okay, so I think that there is nothing for now, so we will continue. So these are the three, again, requirements of SRMPLS, why SRMPLS exists. And basically, those three are our basement to explain SRMPLS. In SRMPLS, we don't have a session-based, we don't need hello packets. Everything is inherent into the protocol, meaning ISIS and OSPF, link state protocols only. So SRMPLS only works in link state protocols. Is extended into ISIS as TLVs, time length values, that you might know, and OSPF as a LSAs, the opaque LSAs. There is where SRMPLS is injected. There is no need to send hellos to enable a protocol, establish an adjacency. This also consumes you more manageability things, establishing an adjacency. You need to care about the adjacencies, another layer of complexity. So that also is removed from SRMPLS. SRMPLS can pair with perform measurements as well. If you have heard perform measurements in the past, perform measurements allows you to calculate the latency across the whole infrastructure, okay? And SRMPLS use that latency to provide a very good traffic engineering configurations. SRMPLS can also be used to provide traffic engineering for the specific customer, right? We were talking a few minutes ago that the reason that LDP doesn't provide proper traffic engineering per customer is not possible. With SRMPLS, you can do it, and it's very easy to do it. And there are 3 ways that you can enable traffic engineering for the customers. We will not see in this session, but there is a possibility to do it. Last but not least, SRMPLS is open to automation. Why? Because it has the SRPCE. Probably you have heard about the SRPCE, but the SRPCE is a device, central device. We can call it like a route reflector, but for segment routing network, okay? The PCE basically can control all the traffic engineering policies that you have in the network, and it's also possible that can provide those traffic engineering policies to all the PEs. So for example, if I have a network like that, and I have here, this is a provider H, and I have my customer A here, and my customer A, and I have my customer B here. I can configure, obviously, the policy of traffic engineering for this specific customer in this device, go and configure and draw it like that, or to the other customer and draw it like that. I can do it, but SRPCE is a central device in the network, like I was saying, as a route reflector, that can hold all those policies and can propagate them to all the PEs in a dynamic way, meaning that you don't need to configure anything in the PEs. Everything you configure on the SRPCE. And there, it has similar requirements as the route reflector from the resiliency and from the high availability perspective. The SRPC only works in the control plane and doesn't work in the data plane. Okay, so that's also another advantage of SRMPLS, that give you and open the doors to automation. Why? Because by having the access to the PEs and the policies in the network, then it can export those policies into a telemetry server or any observability tool that you might have. You don't need to even capture the data from the PE devices specifically. You can just capture from the SRPCE perspective. And obviously from the Cisco perspective, it can also be connected with other technologies like NSO, CNC, Crosswork AI, and there are other platforms that are more automation, that they are connected to SRPC to provide visibility and automation in the network. So with that concept, we can say that SRMPLS is open to automation, okay? So basically, SRMPLS in the transport perspective work in the similar way as LDP, meaning by label. All what I explained for LDP in the transport and the labels that are encapsulated from the customer and propagated, those are in the same way, the same, let's say, design concept is in SRMPLS, propagate labels, but it does through the IGP, ISIS and OSPF, okay? It does based on the IGP protocol through those LSAs and TLVs that I just mentioned. Now, any questions until now from the audience, or any feedback? Victor, you say, ¿Cómo gestionamos? Sorry, I will read it in English. How do we manage the synchronization state between a pair of PC? That's a good question, Victor. There is a feature that is called SRPC HA. If I'm not mistaken, it plans to be, at least in Cisco side, it plans to be developed in the 7 track, almost the end of the 7 track of the XR version. So now we are in 24, 25. It should be already in place. It allows to synchronize both SRPC basically in a stateless, stateful, manner. It's a feature that already exists, and you can put both SRPCs in synchronization. If I'm not mistaken, it's already supported, but I didn't track that for some time. Okay, but it was already in the pipeline to get supported, right? Um, Essentially, it works in the same way as synchronizations of control play devices. For example, for NAT for NAT sessions, there is a feature, if I'm not mistaken, the name HA NAT, if I'm not mistaken. So both keep the control plane of the packets and they synchronize across each other in an stateful way. The same is with the PCs. I can send you later on, Victor, some part of the documentation so you can read about that, if that's useful. And offline, I can also look for where this feature might be supported, at least in XR boxes. Okay, it's not a problem. Perfect. So that's a bit of the concept of SRMPLS, and why all this evolution since peer-to-peer models and SRMPLS has to come, because there was a need of something, right? Now, how you enable SRMPLS, and let's go over the configuration itself, how you make it alive, right? In LDP, we know that we need to enable MPLS IP over the interfaces. You need to enable MPLS LDP router ID to be the loopback 0. Maybe you can enable on the AGP as well with the MPLS LDP autoconfig. There are many ways that you can enable LDP, and it's simple. You don't need to do anything. Another thing of LDP is that if you have another disadvantage that I think is important to highlight, is that if you have too many IGP routes in the network, meaning 4K or 5K in ISIS or OSPF, this will be probably too much. But let's say you have 3K, 4K around, then if you have LDP only enabled, you will create a label for those prefixes for those 3K and 4K, and the scalability or the scaling of the box if it's an NCS or a Cisco box is something good to track, because this consumes databases in the platform that consumes your memory, and those memory are shared. So other protocols also use that memory, and that can create some type of limit in the platform. So by default, if you enable LDP without any secureness, let's say, you can get into scalability if your network obviously is scalable, is with the scale values as well, with high numbers. There is a way that you can put a host route. Probably you have heard about this command in iOS XE or XR. You can enable labels only for the loopback 0, because at the end, the layer 3 VPN protocols, you only care about loopback zeros. You don't need the point-to-point links. And this will assign you labels for the loopback 0 only. So that's another enhancement that most providers does, only to the loopback 0. Now, you don't need to do that in segment routing. In segment routing, the way that you enable it is that you go under the protocol, router ISIS, process IGP, for example. At least in XR boxes, you go into interface loopback 0, because you want to enable the label only for loopback 0. And you enter here under the address family IPv4, and here you define the prefix seed. Prefix seed basically is the label that you allocate to the loopback 0. And this is something that it took care in segment routing. You don't want labels to everywhere. You just want labels to the loopback 0. So that's why when you enable segment routing, you need to enable labels to the loopback 0 or the /32 that you have in the network that you will use for your services. So then you go to the loopback and put the prefix seed, and you put here the label range that you want to enable. Okay. This label range in segment routing is called segment routing global block, SRGB. You have heard also, probably, if you read a little bit of segment routing, is the range of segment routing labels. LDP has a range of LDP labels, which is 24,000 plus onwards. SRMPLS, it has a range specific that is from 16 to 23,999. At least in XR boxes, this is the normal label range for SRMPLS labels, okay? So you enter under the loopback 0 and you enable the label for that loopback. And that's pretty much everything that you need to do. There is another command, just one more command that you need to go over again, router ISIS, IGP, you enter to the address family IPv4, and you configure segment routing MPLS. With that command, you enable segment routing in the control plane, okay? You don't push the box to forward MPLS labels or labels SRMPLS labels. You just build in the control plane. You enable the TLBs of ISIS, you enable the LSAs of OSPF, as we were mentioning in this point, and those start to be propagated. The prefixes that you put in the loopback start to be propagated, okay, with this command. Those are basically the only two commands that you need. You don't need to use much more commands for enabling segment routing in the network. Now, if you want to make the segment routing labels to be used instead of LDP, then there is another keyword on top of that, on top of this one, that is you need to add the keyword forwarding. That will make you to enable SRMPLS label in the forwarding plane to send packets of SRMPLS labels. And this is normally commonly used when you migrate from LDP to SRMPLS. I have a video where I explain this migration of LDP to SRMPLS. It's very easy to do it, obviously depending on the network, but in a network of 100, 200 devices that is not splitted in areas and everything, it's pretty easy to do it. Obviously, if you grow the network in multiple areas and it's 2,000, 3,000 routers, then that becomes more careful that you need to do that, but overall it's very easy to do it. And you need to care about this forwarding that will be at the end. And I will point you to the video to watch how to do that migration properly. Okay. Edwin said, sorry, I was out of the chat. You said, Edwin, what factors are important to consider to change to SRMPLS in the looking at the hardware, Edwin, sorry, right? Can you hear me or is not audible? Because I see that my screen is already shaking. So if you can write that you can hear me and everything is fine, I can continue. Just write something in the chat and or drop some good, and I will be able to hear. Okay, I believe that I am audible. So what factors, to answer you, Edwin, SRMPLS is not a hardware-based protocol, right? So if you want to enable or thinking to enable to your network, it might depend of the software version. That's for sure one thing. If your platforms are iOS XE boxes and old boxes, probably they are with old versions that doesn't support segment routing. But if your platform are XR boxes, most of them already support segment routing in place. Maybe the ones that are 32-bit ASR9K with older versions, they might not support those versions might not support segment routing. But you might need to look in the version of supporting segment routing itself, right? So it's not a hardware protocol itself, it's software-based protocol. Just look in the software version that supports segment routing and track it for the hardware that you want to enable. Now, if you want to enable SR segment routing traffic engineering, and you want to do latency-based traffic engineering policies, then you need to consider another protocol which is called perform measurements, and this protocol is hardware-based. So that protocol might influence on the hardware that you have in place, and you might need to upgrade if that device doesn't support perform measurements. But this is, again, if you want to have traffic engineering with low latency, perform measurements normally is hardware-based protocol. Not all the line cards in the XR boxes support perform measurements, and not all the Catalyst or Cisco routers that run IOSXC support perform measurements. So whenever you think about segment routing MPLS, think also about what features of traffic engineering you will use together with segment routing, and then decide if they are hardware-based or only software-based. Okay, that's a tip that I will do, Edwin. I hope that answered your question, Edwin. Just writing to make sure that you listen to me, otherwise I will need to restart the session because I am not listening anything from you. Okay, perfect. Very good. Thank you, Edwin. That makes me the feeling that is all right. So if that answered the question, Edwin, let's continue with the session. So those are the only two things that you need to consider for SRMPLS. Migration wise, as I said, if it's a small network in the same ISIS domain, the same OSPF domain even, with 100, 200, even 300 routers that are in the same domain, you can enable SRMPLS without any problems. You need a maintenance window, of course, to make sure that nothing will happen, but the disruption is very, very minimal. It's even not sensible for many applications. Okay, and the step one that you do, or the steps that you follow, is step one, you enable SRMPLS in the control plane. So you need to enable segment routing MPLS. You also need to enable prefix it. You need to define your segment routing global block. All you configure in the devices, you can configure in all the devices in the network, because it's a command that will not affect anything. And the step two can be that you, from those 300 devices, you start to enable or adding the keyword forwarding that we commented here in a few minutes ago. You add the forwarding keyword to the segment routing MPLS, and then it will start. Every device will start forwarding the traffic in using the SRMPLS labels. The others will forward in LDP because they are not enabled this keyword with the forwarding, and that's still fine. It can coexist that you have one device running SRMPLS forwarding and the other run only MPLS LDP labels. Those two can coexist. Technically, and it's proven, it can work out, right? And you can segment your maintenance windows in 3 or 4 to do 50 device or 40 device in one, and split somehow like that. Or if you are very caring about any disruption in the network, of course, or even put a pilot test first of a bunch of devices, 10, 20, and you, in this pilot phase, you enable segment routing, and the others you leave with LDP, and you can leave it for some time to see what is the behavior. That's also another way. When you have too many devices in the same ISIS domain, you can create a pilot. But if your devices are 30, 40, 50, 60 devices, kind of enterprise network, you can do in one shot all the devices, and that will not cause any problem. Okay, perfect. So this is a little bit of segment routing. I think that we crossed the time. We will not have time for the lab that much, but I want to show you anyway something. I want to show you how you enable segment routing in the device. Okay. So let me share my screen now. I have this network that I have in the drawing that I am sharing. Now I will share my session with my I will share my complete screen so then you can see it. Sorry, I will share just my session tab. I hope that you can see my session tab now. Is that visible? Oh, thank you very much, George, for the support and for being here. Obite as well. Thank you very much for joining the session. There were many failures in the connection and transmission and internet, but some made it. So thank you for supporting and joining. I want to show you here in one device. Maybe XR1 is the one. I am running XRV. I will define just the password. I am running XRV software, okay? So here I will just define the name, right? And here, the way that you can configure segment routing is that you go to the ISIS process, let's say IGP. Obviously, here you need to type different type of keywords in addition, but here you configure segment routing MPLS. This is a command that I was telling you to enable the control plane. Now, the prefix seat you can enable with address family plane for unicast, and here you put prefix seat. There are two ways to do it. Absolute. Oh, the screen got frozen. Thank you, White, for sharing. Can you see now the screen? Is that very good now? Okay, perfect. Thank you, White. So I can put index 10, or there are two values here, index or absolute. I didn't explain that, but I will quickly do it. Absolute, you can define specifically the value of the label that you want to define for this loopback 0. Completely the value. For example, 18,000 I define for this label. With index, you need to only define any value. You can define any value, and this value will be summed up to 16,000. That is the beginner number of the segment routing global block. And that will be the final label that will be assigned for this loopback. So you have two ways to do it. It depends on the preference of the providers. I have used index, I have used absolute. Initially, it was thought that that absolute is better, because it's fixed value, and fixed value can help to do more automation things because it's a fixed value, so it's predictable. But with index also, you can already adapt into any script, and you can already run some automation things. So really, the way how to do it is independent, and is on the preference of the customer or of the network. Obviously, you can, if you have 3 regions, for example, where your core network is in 3 different continents, you can say that 16 to 17 will be for region 1, 17.1 to 18,000 will be for region 2, and 18,001 to 19,000 to region 3. You need to create that logic how to do it, so it's in a smart way, so it will make sense, let's say, right? So okay, so you configure absolute value here, and that's pretty much all what you need in segment routing. The interface loopback 0 with the prefix seat, and you need to enable SRMPLS there. Here, I will try to enable. I will try to create something very basic, so we are also doing something in the network. I am using here the interface giga00, so I will enable an IP address just to create the routing of ISIS. So I will show you how segment routing will work. You need to put, obviously, in ISIS the interface, address family. You can put point-to-point as well. And here I'm just finishing my ISIS configuration. Reality of segment routing, I just need this command and the prefix it, and that's it. I don't need anything else. In ISIS also I need the net with the area, so I will enable that. And that's pretty much it. There is another keyword that also is best practice to enable in XR, that you configure segment routing, and here you put the global block. And you can define here just your global block as you want. Normally, this is left by default, so you configure all the parameters just by default. And that's pretty much it, my configuration. I just do commit, and I go to XR2, and I do exactly the same. Here I will just go quickly to R2. I think that here I set up the password wrong. So I will go this one. Yeah, so I am now in R2 that is connected to R1 by the Giga00. So I will put XR2. I will create a loopback here. I will also type in the Giga00 10, and I will enable ISIS with level 2, segment routing MPLS, as we know, interface loopback 0, with prefix seed absolute 18,001 as well, and under interface 0. Oh, I am sorry for, yeah, thank you for telling me that, George. So now it should be very good, I believe. So here I'm just going to R2 and I'm figuring a basic IGP configuration. Okay. So interface loopback 0, the prefix seed, the interface Giga00 as well with the address family. And I missed it here to enable the net ID. That will be 2 and IS type level 2. That's pretty much what I need for ISIS, and I need to enable, I configure the interface and I configure the loopback 0, so this is very good, and I do commit. Here in XR1, I think I missed the loopback 0. Oh, again, it got frozen. I don't know why it does get frozen quite often. In XR1, I missed the loopback 0, so I will enable a loopback 0 just to have it in place. Okay, so I should have adjacency now. I should have an adjacency, or at least I should ping to 10.112. Okay, something is going wrong here. 10.112. What I have in the interface, 10.111. Okay, I think I configured in the wrong device. This is peering to XR3, not to XR2. So then I will just configure to the right device, and I will do here no router ISI. I will just edit R2 configuration. Again, I stop sharing, so I don't know why it stopped. And I will go to XR3. Oh, sorry for that, but somehow it stopped to share. I go to XR3 to configure what I had in XR2 because the device was in R1 with it was connected with R3. So then I enter into the gigabit 00, and I will configure the IP address 1112, and the loopback I will put 3333. And now I should have ISIS session with both devices, between both devices, and also should have, yeah, and also I should have the loopback of router 1. This should be, yeah, there you go. So I have now the loopback, and I can ping. The easy way to see if MPLS works, or sorry, the segment routing works and labels, is to enable MPLS OAM. MPLS OAM is a correct, Georgie. George, it got stuck every time that I switched to another window. I also spot that. Thank you for the feedback. So MPLS OAM allow you to do trace out and ping. That's it. there is no more science of MPLS OAM, to be honest. It allows you to do ping and trace route for MPLS, for labels. That's pretty much it. OAM is optimizing administration and management, if I'm not mistaken, but it just gives you trace route and ping for MPLS labels. So I enable here. So I will do a ping for the loopback 1, sorry, ping MPLS, IPv4 unicast, or IPv4 for loopback 1, that is the loopback of router 1 that has segment routing, and I will do source my loopback 0. Well, source I will do 333. Okay, here it doesn't reply because router 1 doesn't have MPLS OAM, so I will do MPLS OAM here. I will not stop sharing, I just enable MPLS OAM there. I miss an important keyword that is very important in ISIS is metric style wide. Without that, it will not work segment routing. So I need to enable also metric style wide. These are very important because these enable all the TLBs that are existing for segment routing. There you go. Now the ping works. So metric style wide is a key part for segment routing labels to work because it enables the TLBs in ISIS and also the opaque LSAs in OSPF. Now, I am in XR3 connected to XR1. I will show you a little bit of the database, what it has here. Let's take a look. Verbose XR1. I will check ISIS database, what XR1 is sending to me, okay? So what XR1 is to me, if to the ISIS label, this is all control plane. I don't have MPLS in the forwarding plane. Everything is control plane. The ping works because the ping is triggering traffic in with labels, but I don't have labels in the forwarding plane as of now. But I can see what is in the control plane. In the control plane, there is, as you can see, many of the keywords segment routing, the segment routing global block. There is the prefix index that I configure as an absolute. So my absolute from XR1, if you remember, it was 18,000, right? It calculates the index automatically, which is 2,000. The difference between 18 to 16,000 is 2,000. So that's why I put 2,000 here. Pretty much that's it. Some values as well for segment routing that are here. The most important are make sure that the global, this is another important tip, segment routing global block normally is same in all the network. And you must keep it like that. Otherwise, your management part of the network will be very, very messy. It's very good that you keep all segment routing global block straight away similar in all the infrastructure. You can change per device, but it's not recommended. The manageability will be very hard to associate and to do troubleshooting in the network. What else we can see here? Show segment routing, MPL, show segment routing, show ISIS segment routing label table, for example. Here we can see the prefix it. For my loopback of XR3 is 18,001. For the loopback of XR1 is 18,000. So I can see the label. And if I check show MPLS forwarding, the MPLS forwarding is the same keyword that you use for LDP as well, for checking the forwarding of the traffic. If you remember, in LDP, we use show MPLS forwarding as well. In segment routing, nothing of this change. Forwarding, it still is forwarding for segment routing MPLS as well. Forwarding, it shows that the table is filled, right? So you have outgoing label is pop. Here also in segment routing MPLS apply the concept of pop, push, and swap that we all learn in LDP. If the neighbor is directly connected and has a loopback directly connected, it will use a pop label. It will not send the label for avoiding this double lookup of labels. This double lookup adds a little bit of delay and is not desired, so that's why it automatically is enabled the pop in the last last router of the network. And here you can see the SR prefix is 2000, the index. It got automatically calculated, even if I put absolute, and there is no traffic in that label. So until this point, what I configure now, prefix it and segment routing MPLS, is what you can do in your network without any disruption. Now, whenever you migrate, then you need to do, and you want to put labels in the forwarding plane. By the way, if I do show Ceph 1111 here, yeah, now it's implicit null, so this is good. So what you need to do in your network to switch from control plane to forwarding is to add the keyword show MPLS segment routing MPLS forwarding. So forwarding, it can be forwarding or it can be SR preferred. There are these two, and depends of the iOS XR version, depends if it's iOS XE as well. In iOS XR in this version is SR preferred. Okay, and you just do commit, and pretty much that's the difference from enabling segment routing in the control plane and enabling in the forwarding plane. SR preferred. Okay. I think those are basically all the commands. These commands here are not much relevant. Label table, show Ceph, you verify that to that loopback you have a label. So it's in post label, that should be in place. And show MPLS forwarding, where you have the label to the loopback of the P1 in our case, right? Now, if I do traffic ping to using my loopback 0 to loopback 0 of P1, and I do a lot of traffic, for example, I will put, now I should see in the forwarding the traffic going on. This is also another keyword that you use, or command that you use for troubleshooting. MPLS SWAM you use for troubleshooting, and this one as well for checking what bytes or traffic go into the right place for the traffic. Perfect. That's what I wanted to show you today, and what I wanted to do a small lab for segment routing. We extend a lot the time, but thank you very much for staying in the session. Even that we had a lot of disruption and a lot of cuts and shutdown of the session, delays, and I was accommodating things here. I hope that still the knowledge was useful. I don't know if there is any comments or questions until now. Obviously, aside of the configuration part, maybe more design or troubleshooting questions that you might have, or any type of question that you might have. Feel free to do it. And if there is no question, we will close the call. George, you say, I can imagine how hard it can be done in a brownfield. Yeah, in a brownfield environment, George, is much harder, of course, and obviously it shouldn't take it like easier. Reality is that it's easy, that is not disruptive to enable segment routing. It's not that disruptive. Specifically, maybe it can sound a little bit disruptive because TLFA, and this is a point that I didn't touch, but segment routing, TLFA, if you have heard, is only supporting SRMPLS. So normally, if you want to enable SRMPLS, you also want to enable TLFA. LDP runs remote LFA that doesn't cover 100% of all the backup paths across the network. TLFA covers full, completely, always you have a backup path in the network. So if you implement SRMPLS, you might also think about if you want to enable TLFA in the network. And TLFA also is not disruptive, but it changed the way that you calculate a backup path anyways. So that can add a more nervous, let's say, to implement in an environment, definitely, yes. Because you are touching a protocol which changed the paradigm of how to calculate a backup path, and probably reshuffle the route in the routing table, and eventually that can cause a little intermittence. But for my experience, it didn't cause any problem when I was doing that. in a production environment, but it might be for some probably applications, very sensitive ones. So definitely, Georgie, is something to to do smoothly, let's say. No worries, George, and thank you for watching all the videos. So if no more questions, thank you very much for watching the session. I promise that it will improve the next one that we have with SRV6. There will be this one with SRV6 approximately in 2-3 weeks. I think I will send the link um, over the channel. I will publish also in LinkedIn, and also for you can register to that session. You will receive an email as the ones that you register. You will receive an email for the link. I promise all this logistic will be improved, and also the structure a little bit. It was my first session in YouTube on live, so also it's an experience for me. Actually, second, but the first one that I talk a bit technical topic. So I try to do as I do in my classes. This is the way that I do in my classes and in the bootcamp. I always use the board, and later I use the lab if needed. So this is the way that I teach, and I hope you have learned something and it was useful for you. And subscribe for the next session for SRV6. I will send the link, the description, and we will talk about all the things that we talked today as well. And if you have any questions, obviously you can do it on live. When to migrate, what to consider to migrate, brownfield or greenfield. So everything what you want, we can extend to 1 hour, 1 hour and a half session, and we can deliver a content that you would like to. By the way, I also do courses. I am doing a bootcamp soon that will be in the third week of September. That bootcamp is target for CCIE service provider. So it will be a 4 or 5 days in bootcamp intense for around 5 hours. I have delivered that in the past as well. If you would like to join, send me an email. There are people already enrolled. I am trying to do this limited because I want to save the space for learning, of course, with few people. So if you want, feel free to send an email and register to that. And of course, register for the next session that will be for SRV6. Thank you very much, everyone, for watching. And I see 13 person, and I'm very happy to see that number, and that we are people listening here and supporting. So more videos are coming as well, and tomorrow you will get a one for SP Technologies. Thank you very much, everyone. Have a nice evening.